Hey, hello everyone. Assalamu alaikum. So I'm Muhammad Shahri Al Mustaqim Mitul, and you can call me Mitul Shahri as well. Okay, so today this is our one of the expert talk sessions of ML School Bangladesh. So today we have with us Bill Wilder, who is a Microsoft AI MVP. Same time, he's an adjunct professor at Pitt University. At the same time, founder and co-organizer Boston Azure AI community. So without any further ado, so we'll just invite Bill to the screen and we will talk with him. Can you hear me?
Yes, I can hear you. Good evening,
Great. Thank you so much.
Mitul. Yeah.
Yeah.
Should I take it away?
Yeah. Thank you so much for accepting our invitation. Yeah.
All right. Mitul had mentioned it's 8 p.m. Where you are
Yes.
in Bangladesh.
Yes.
So thank you for everybody for it's extra credit for coming out on a Friday evening this late to learn
Yeah.
AI and ML concepts.
Yeah.
For me,
Thank you
it's
so much.
10 a.m. in my
Um,
morning. Oh, go ahead, Mitul.
no. We would love to know like something about you. If you introduce yourself, then we can get started.
Sure. Um, I'm in the Boston area. Here's my, oops, what's going on? A little bit about me. Uh, Mitul had already mentioned a few things, so I won't go too deep. My current day job is Chief Technology Officer of a company called Open Admissions, which is a AI first uh, ed tech education technology startup. And I live in the Boston area with my wife, and I have 4 sons. And looking forward to chatting with you about AI for the next 45 minutes.
Yeah. Awesome. Let's get started.
All right. So for this talk, we have humble goals, two. I want to give you a not deeply mathematical, but we will look at a little bit of the calculation because I know this group is trying to learn the math. So we'll get a intuitive understanding of how AIs are able to understand human language or process human language as accurately as they do. And then we'll connect the dots a little bit, as we say, to how that might help you. What are some of the tools and techniques that are in the AI ML space that this unlocks? We'll take questions at the end, so feel free to build up your questions. We leave plenty of time to answer any questions. So I'm going to start with the world's quickest history of AI. It started in the 1950s. There was a conference, and a programming language called Lisp was created to support it, and it started to take root. But not a lot happened for like half a century. And then machine learning came onto the scene this century. And that is what is powering so much of the AI and ML space these days. You know, it's in the arc of human history. It's pretty recent. So the 2000s, and then the world changed in November 2022, less than 3 years ago at this point, when ChatGPT hit the street, and we all were astounded by its power, accuracy, and suddenly, as an engineering community, we're able to do things programmatically that had never been possible before in the history of computing. You have code that uses these models, process human text in ways that were more accurate, more just generally more powerful. We could create summaries, all this kind of stuff you're all pretty well aware of. But that all changed, very recently. And we're going to talk about one dimension of that, which is the language understanding and how that is integrated into the AI space. I'm going to say AI more than ML, but by this brief history of AI, you can all appreciate that we have AI on the outside, ML on the inside, and then the other AI inside of that ML. So when we talk about AI today, we usually mean the inner one that's powered by by machine learning. All right, we're going to start off by looking. Let's just jump to a couple of demos just to establish context, and so we're all talking. No, we're going to kind of dig in a little bit, and then we're going to work backwards to explain how we got here. So let me drag my web browser over there. So I'm going to start with just ChatGPT. Tell me a joke. This was not possible before we had GPTs. That's a terrible joke. Uh, uh, what is water? Right? You can. All this text is made up on the fly, based on the training corpus with which ChatGPT was created. So just demonstrating, like, reminder, like this is what happened in 2022 that changed everything. We could suddenly have these capabilities. But I'm going to factor out the language part into so there's a generative language part here where this response was synthesized by the large language model. I'm not going to talk really about that. I'm going to talk about the input. And I'm going to factor that out into what the AI world will call an embedding model. And we're going to talk embedding models for a little bit here, and then we'll fill in some other background details. So an embedding model is what semantically represents human text. And also, I'm going to talk about text today, even though these same concepts can apply to video, audio, other media. But just for simplicity, going to talk about text only today. And I have this. Where'd it go? I have this app I wrote, and it's out there on the net, and you can access it and play with it, and it's running all the time. The source code is here. We'll look at a little bit of the source code because there's math in there. But just to orient you, let me just start first. I'm going to say young dog and puppy. And I hit enter, or you can press this button, and it gives a little histogram of how semantically similar the text on the left and the text on the right are. Young dog versus puppy. And it's very similar. It's a 0.68. This is a scale of 0 to 1. And again, this histogram is kind of meant to give you a visual representation, so you don't have to work as hard to understand what 0.068 is. So this is a young dog in the English language is often, we have another word for that, which is puppy. We could do dog and gent and compare these. This is dog in, I think, French. And so I'm pointing out that it can work across languages, across human languages. It can even work with code, as an aside. And I have up here, you can certainly play with this. So raining, and I'm trying I don't natively speak any other language other than English, but we can try
Yeah.
raining. Yeah. So does a terrible job with that. Um, uh, but often it works. So we can, so I know Bangla is a popular language, so there should be a lot of training data on it. But if we, a rainy season. And it did better. This is actually a reasonable correlation. So the point being that that this tool is is doing a semantic comparison of two phrases, and it's giving a score of how similar they are. I have a graph that kind of drills into a couple of graphs that drill into this in a little more detail, what these numbers mean. But if I say rainy season and dry season, you might think of these as opposites almost, but they're conceptually the same thing. We're talking about how much rain is coming down, and it's a season part of the year. So they're actually conceptually very similar. So the semantic comparator treats them as such. This is a very high similarity score, even though it's when we're young children, we're taught that wet and dry are opposites. So maybe we could even try literally those words. So that's even even higher correlation. So in the world of semantic comparison, in the AI ML realm, these concepts are very similar. How much liquid, how wet they are. Okay. I want to point out a couple other things on this this application. One is the code is there. I think I mentioned that. Another is it mentions that it's using a model called text embedding 3 large. And this is a model that is not a large language model. It is a different kind of model. Mostly we hear about large language models, like that's taking up all the conversation. But there are other kinds of models too. And an embedding model, which this is one of those other kinds. So I'm going to hop over to when I put Azure, here it is. So this is the Azure AI Foundry portal. You can access it through ai.azure.com. And there, within that, there's a model catalog that allows you to view and select and deploy models that are available in this catalog. And if you look down in the bottom right, there are more than 10,000 models available, 11,119 at this moment, it looks like. And if you go look at the models themselves, you see ChatGPT, which you see the GPT-5 model, which backs the updated version of ChatGPT. That's available, and there are 10,000 plus more models available. I'm going to filter here on capability. No, I want inference tasks. Yeah, I want embeddings. So there are 83 embedding models. So if I check this filter, it's going to go from 11,000 plus to just 83. And I'm just going to search for OpenAI. And that narrows it down more. So you can see this model here, text embedding 3 large, is available for me to select and deploy. There are other models. This model came out at the same time. These were about a year and a half ago, at the beginning of 2024. These were released by OpenAI. This is an older one. This was used in a prior generation of GPT models. And interestingly, so this came out in early 2024. There was no new model released alongside GPT-5, which dropped, I don't know, last week or something. So these do not have the same update cadence as the LLMs do. So just pointing out, like, this is a model treated similarly to the large language models, but it's not a large language model. It has different capabilities and it's used differently. And I went into this. So this is the Azure AI Foundry. There are other portals that you can use to access models and deploy them and manage them. I just happen to be using Azure. But I went in here and I deployed this in order to create this this application. So behind the scenes, it's programmatically accessing this model, this specific embedding model. Okay, so I wanted to establish some context here. This text embedding 3 large model is semantically comparing these two phrases. And note that the words don't need to be the same. and you get still super high correlation if I change from season to time of year. There are no words, no lexical, uh, uh, nothing lexically is identical in either of these. And this is, I'm trying to emphasize the point that this is working on semantics. It had, and we'll talk about how this came to be, but there's a semantic representation of what's expressed in these words. And final point before we go on to back to some slides is the application is called Fun with Vectors because that semantic representation is expressed with a many dimensional vector. In this case, a 3072 dimension vector. So this phrase has been, by the embedding model, the one that we saw in Azure AI Foundry, that this phrase has been decomposed into a 3000 plus dimension vector. And this one has been decomposed into a 3000 plus dimension vector, 3072 floating point numbers essentially. And then when I hit the compare, it performs a calculation that's known as cosine similarity analysis that many of you may be aware of, and we'll look at the code to that right now. So let's tidy this up. So this is the Git repo for the Fun with Vectors application, and there's a vector math .cs file, and you can read that most of these yourself. But I'm just going to look at the cosine similarity calculation, and it only performs accurately on vectors that are the same length, and these are all unit vectors. They're all of length 1. And it's accumulating a dot product, and it's dividing it by this formula, the square root of the multiplication of the two dimensions in each vector. So it spins through them all, and it's accumulates these values. I'll just let you look at the code here, and then it does it calculates a dot product on the way. Then then it does a division here at the end. That's the formula for cosine similarity. I didn't make it up. I looked it up, and it's a pretty straightforward calculation to understand and operate on. So there's a little bit a glimpse behind the scene of how this number is ascertained. So it's a combination of 3072 floats, a second set of 3072 floats, and that calculation we just saw in the code. All right, so I'm going to move on. Let me go back to the slides for a little bit. So we looked at ChatGPT, Fun with Vectors, and the Azure AI Foundry portal. We already looked at this, but this just to emphasize the point, alongside GPT-5 now and GPT-4, and the embedding model sits there, and there are other kinds of models too. This is not a LLM for text; it's an LLM for creating images. So that's all in the. I'm supposing this models as a service acronym to go along with SaaS and PaaS and so forth. And I'll point out that the OpenAI model is not super well documented. The innards, they're not publishing a lot of detail about how it works inside, but it's rooted in this most famous AI paper that, again, many of you probably heard of and read. It's a good read. Attention is all you need. And I when I was putting together links for this, I realized that they've come out with they have 7 versions of it. It was originally published in 2017, but as early as 2 years ago, there was another revision. So you can read more about it there. And to emphasize a few points, an embedding model encodes your text into vectors, and I have text in quotes here because it's really tokens, and we'll talk about tokens shortly. Vectors are semantic, as we said, and they represent meaning. It's not a lexical process. We can say time of year, or we can say season, and they have a similar enough meaning that they're understood as similar to the vector model. Um, I think that's sufficient. And let's talk about vectors. If this is a mathematical crowd, I think you intuitively probably have some understanding of vectors, but in case anybody doesn't, I'm going to talk about vectors for just a minute. This is an old school analog clock. This is the kind of clock I had when I was a kid, before we had these fancy digital ones. And what you see on screen there, you might think of as the hour, minute, and second hands as three very simple vectors, all originating from the same spot in the middle. And in the cosine similarity calculation, we would take two of those vectors and compare them. So you can maybe ignore the second hand that's pointing at the 7, and we'll focus on these two. Except for in the embedding model that we talked about, we have many, many more dimensions of vector in each vector. So instead of just starting at an origin and pointing at, in this direction at roughly 10, it can start that way, but then there's another dimension of the vector. Maybe it's coming towards us off the screen. Then there's another one that might be going at an angle up to the left, and then a third, fourth, a fifth, and all the way up to more than 3,000 dimensions. And same for this. And then we saw the mathematical calculation that would compare the two vectors. And they were also happen to be unit vectors. But just for the intuition, this is like there's a dimension. There could be another dimension that goes up here, another dimension over here, another dimension that comes right at us, and so forth. 3,000 dimensional space that we're in there. So it's the intuition on a little bit of the intuition on what it means to be expressed as a vector. I think I probably talked enough about this first point. I'm going to make a comment here that the cost of this, I haven't actually revalidated this since GPT-5 dropped, but as of the prior model, right before GPT-5, the cost was $13 the US cents, 0.13 per million tokens. So just so you know, the token we'll talk more about shortly is a unit of semantics, but it's also how you pay for your embedding model, and it's also how you pay for your LLM. And once you have use the embedding model to create the 3,000 plus vector dimension vector, the rest of it is math. Like to do the cosine similarity, you don't have to pay them to do that. You can just do it in code like I showed you. Okay. And this is just a link to that particular file that shows the cosine similarity calculation. And I don't know if you all in Bangladesh call it math or maths. I grew up with math. I know parts of the world say math, so trying to be inclusive. This is one of the charts I mentioned. And just to let you know the evolution of embedding models, the spread is growing. They're becoming more nuanced and more subtle. And this is so this is basically saying that with the labels here, they're pretty unrelated concepts if you do compare two texts and they come out close to 0. And then weak similarity is about a quarter, mild about a third, or up to 0.45, and then we're getting into moderate, high, and extreme. It's pretty hard to get I've never been able to get a 1.0 similarity except in one very special case that I'll leave unstated for now in case you want to try it. And I have been able to get very low and even negative correlations by using very specialized text for super unrelated things. But it's been interesting for me to experiment and try to get using the Find with Vectors tool to see how much of a spread I can get semantically. And again, this is an older model. This was also in the model catalog in Azure AI Foundry, but we could put that in Find with Vectors and would see different semantic results. So one of the points of this graphic is that all embedding models do not work identically. You have to know the embedding model you're using to understand what the meaning of the outputs are. When it tells you it's a 0.5 or something, that means something different depending on the embedding model. And you can get these slides later. I'm going to post them. I'll show you where you can find them. But these are some things you might have fun with in the Find with Vectors app. Can you find a perfect match? I doubt it, except in one special case. Can you find two phrases that are really far apart? Probably. Can you get to 0 or negative? That's harder. It took me a long time to figure out how to do that. Do phrases in different languages match? I think we've seen some mixed success there. It's a little trickier. And again, that's like when we compare different embedding models, that can be a way that they vary as well. Some will do better across languages and some less well. And this is an interesting one. What about punctuation, spacing, or capitalization? Does that matter? So these I'm inviting you to play with on your own. And I want to make another point about embedding models. If we go to the Find with Vectors app and we type in doctor and DR, and I don't know if this internationalizes, but in the United States, at least, we use DR as an abbreviation for doctor. And so these have a pretty high correlation, DR and doctor. And then physician is another word for doctor. And that also, similar correlation. But that doesn't mean that physician and DR are similarly semantically close. So just pointing that out, that the relationship we would say from graph theory would say that's not transitive. So embedding models, they play a key role, and it's important stuff. So I'm going to go into some background topics, but before I do, I want to go in here and give just a couple more examples. While one, and forever. Wait, no. Okay. So just pointing out that this is valid. Let me put a different. I'll put true in there. This is a valid programming language construct. So I wanted to show that the semantic understanding extends to non-human languages, and just to point out too that it also can roughly do a little bit of math. So it's combining these. The plus is treated, if it's not, the plus is treated, plus and minus are treated differently. So that could matter when you're playing with, if you're trying to figure stuff out, part of the challenges I had on the slide. All right, so let's go back to some slides here, and let's talk briefly about tokens. So there's a tokenizer. I'll go there in a second. We'll look at that directly. But you type in some words, and the tokenizer breaks it up into tokens. So token is an AI word. It's a important concept. In the colloquially, casually, we call them, we have words and characters, but the unit of semantic processing and charging of you when you use these, programmatically, is the token. And in this says winter is a token, is a token, and coming is a token. Note that the space is part of the is, so it's actually a 3-character token. And similarly, you see the space comes with some other tokens. Um, these tokens all have identifiers. So the space IS token has an identifier of 382 in this model, and lowercase w for winter and capital W for winter. Since they're not identical, they have different token identifiers. And this also gives you a hint. This is 170,000. This is how many, there are more than this, but there are a lot of tokens, a lot of distinct tokens. All capital winter, again, tokens are all different. This also has a new line token at the end that's not visual. So that's this guy, 198. So the platforms break the embedding model specifically, or the LLM, it's the same technology, break your words up into tokens for internal representation and processing. And let's compare these two sentences too. Note that I'm from Boston. Note that capital B Boston and lowercase b Boston are processed into different tokens, as you know from here, where the capital W and the lowercase w matter. But here I wanted to point it out in the case of Boston, as an example. Boston capital is all one token with the space before it, and this is 2 tokens. And why? If you think about how this works, is these tokens are identified at the time when when the model, there's a model creation process that's hugely expensive. It ingests the entire public internet effectively. Anything that's freely available is probably part of this training. Other resources are part of the training. And in all that vast resources, you might think about it as the collection of human knowledge. The token or the word Boston with a capital B appears wildly more frequently than Boston with a lowercase b. Therefore, it decided that that this is deserving of its own token because it's a concept that has a semantic value. And so let's give it that's what you do when you find something like that. You give it its own token. And lowercase Boston certainly appears, but it's way less frequent. So it was not token worthy. Didn't get its own token. It's broken up into 2. Okay, so let's go look at this. Actually, just for fun, we can do. And they're pretty similar, even though this doesn't get its own token. Or maybe I give it a space before that and a space before that, see if it changes. Doesn't in this case, but sometimes spaces matter. See, the correlation went down slightly just because I added an extra space there. And I could make that home and changes again. So there's a lot of subtle stuff there, but hopefully you get the main point. Now, the tokenizer, like embedding models, I showed you how the embedding models have evolved and the meaning of a cosine similarity calculation has been adjusted accordingly. There are also tokenizers that are model specific. So one tokenizer can work for many models, like this is for GPT-4 and GPT-4 mini and so forth. Note that GPT-5 is not yet in the public tokenizer, which is interesting. But what I can do is, oh, maybe it will if I log in. I'm not sure. But anyway, that's not that important. So Austin is my home, and it shows you what the tokenization breakdown is. And when I have a space before Boston, I can see that both Boston and Space Boston have their own tokens. Um, like Boston, Bangladesh has its own dedicated token. Although without a space in front of it, Bangladesh gets 2 tokens. Period gets its own token, etc. So this is all this is showing is the mechanical properties of the tokenizer. And again, this tokenizer, the boundaries of the tokens were semantically identified when during a training process where the statistical relevance of each potential token was considered as the entire corpus of human language was being processed. All right. I mentioned this, that tokens are the unit of pay. It was of paying for LLM or other model use, like the embedding model, and they were 13th US pennies per, I think it was 1 million tokens. And for an LLM, so that's for any use. That was the pricing. For an LLM, if you type in, like at the beginning of this talk, we said, what's a tell me a joke, and it did. You paid for the tokens that were part of tell me a joke. Actually, let me just go there for a second. So you'd pay for 5 tokens to ask it to tell you a joke. Then if the joke was, something, you'd pay for 8 response tokens. So you'd pay for 8 plus 5, 13 tokens to get that joke response. That's the unit of charging at least in the OpenAI world. In my experience, other platforms are similar. Okay, let's go back here. And then a few words on LLMs. Again, this is an LLM. This is an LLM, DALI, but the text embedding model is a cousin, but it isn't exactly an LLM in the same sense. Its focus is a bit different. You can, and for the LLMs that you can programmatically deploy these. Some you can run locally, by the way, which is pretty cool. I'm on a laptop with 24 gigs of memory, and it runs some models pretty easily. They're not super fast like they are on the cloud, but and it's a 3-year-old laptop. So the large language models, you can run them locally. You can call them programmatically. You pay for the prompt in and the response out. So let me talk for a second about RAG. Probably a lot of you have heard of RAG. It's an abbreviation for retrieval augmented generation, and it is basically a pattern that allows you to add more context before you send a prompt to the LLM. And the way it works is, suppose you have a lot of data. Suppose you have a very small amount of data. You don't need RAG. You just pass the small amount of data in with your prompt, and the LLM can handle it. You give your prompt, and you say, essentially from this data, tell me the top 3 sports teams in football. What I would call soccer, but you might call football, or cricket or something. Tell me who the best 3 cricket players are. And it could do stuff like that, as long as you give it all the data in one shot. But typically, companies or the world has too much data to fit in one prompt. So what you want to do is you want to find just the right data to put in the prompt. So if you had a lot of data about sports and you just wanted to ask a question about cricket, you could use the semantic comparison that we see in the Fun with Vectors tool to scan through all of your stuff and find the topics that are about cricket and the players. And you can filter out the stuff that's about not cricket, you're basically using things like cosine similarity analysis, and saying like some threshold below this, I'm going to assume it's unrelated. And then you gather a much smaller amount of data that hopefully, or you can keep paring it down until it, take the highest probability ones, the highest cosine similarity scores, until you have a small enough amount of data that it will fit in a prompt. Then you include it in your prompt, and then you send it to the LLM, and then it can process that. But the point is that since it has much less data to worry about, the LLM can handle the processing, the amount of context window that the LLM has needs to be accounted for. So that's how you fit in the context window. And that RAG pattern is pretty popular, been popular for a few years now. And that's basically that semantic lookup is how vector databases work. They do the cosine similarity calculation on various chunks of text. There's a whole literature on how you chunk your text, but to find the most relevant stuff that then you can ask the LLM to operate on. And kind of amusing, this last bullet, an LLM is basically a next token generator. So we saw the tokens breakdown, but when you're getting a response, the LLM generates one token at a time. There's some probabilities in there, so you don't get the same joke every time and a response, things like that. But that's an interesting fun fact. So the token is the unit of prediction. And I am getting to the end here. I'm going to leave these in there if you want to look at them. Yeah. So prompts carry a lot of context. You can do RAG, you provide grounding material and so forth. But the point as it relates to this talk is the semantic comparison element. Okay. So back to the human language being the new UI, which is the title of this talk, and how let's pull that all together. A couple of years ago, I guess in 2024, this guy, Jeffrey Hinton, who was on that paper about attention is all you need. He was at Google at the time, considered godfather of AI. He won a Nobel Prize in physics for his work on deep neural networks. And this is foundational AI work. His was in the machine learning realm, of course, and gave rise to all the stuff we see today, the LLMs and the semantic understanding and so forth at scale. He won other awards, but basically, like, pretty big deal. And then summarizing here, human language as UI. In the ChatGPT case, it understands the meaning in a request. You ask it questions, and it's used to generate semantically relevant responses. And I think we've covered all this. And in the interest of time, we're just going to skip ahead. I mentioned RAG. It just defines semantically relevant context. Embedding models make all that possible, and that's how vector databases work. And anything else I want to mention here? I think I've covered it all. Okay. So I also mentioned that the embedding models also are what help us do things like understand code. You can understand semantics in code, like you saw the infinite loop in JavaScript code was matched to the human phrase, the human language phrase, infinite loop. So I'm gonna just bounce over here. I'll make some resource. These resources are all available to you. The Final Effectors app is out there and it's running. The tokenizer's out there. I pulled a slide from Brief History of AI, and I'm going to put this deck on my blog, blogcodingoutloud.com. And so you'll find it out there. I'll probably post it later today. And if you do want to check out Boston Azure AI, you can find us. There are videos on YouTube, and we host online events from time to time. So with that, let's see what you have for questions.
Okay. Okay, folks, if you have any questions, feel free to ask. And obviously, the video will be in YouTube, so you can ask questions later on as well. So I will pass to Bill as well. Okay, so I believe this session was going on and semantic. So I believe there was a question about uh, can the semantic score, semantic score can be in negative. I believe you have answered that right. Sometimes you have found negative, right? Some so yeah, that was one of the questions. So that was um yeah, other than that we don't have any question right now, but if you have any questions, guys, feel free to ask right now. This is your chance. So okay, other than that, I believe if with 5 minutes, if there are no questions, obviously we'll end the session, but I have some questions to you. So I believe that the title and the description was mentioning like um, when you first time used ChatGPT, right? It's a revelation, obviously. So as you mentioned again, so we started, we have input some prompt, then we got some output, right? So what was the journey to learn about that, right? Okay, so you have used that maybe 2022 or something like that, something around that. So found out about that, or what was your expression about that, or how you learned about these things, the mathematics behind it. So can you just tell us about like how you understood the concepts, and so that folks can also learn. I believe the main goal for the folks is obviously there are a lot of concepts you have talked which obviously they haven't understood, some things they have understood, that is normal, right, in everything. So how can they break the things down so they can learn, okay, this is how the whole LLM model work. How was that for you? That's my question.
Yeah, so I've definitely been on a long running journey to learn this stuff. I was aware of machine learning and AI for a long time. I've been in the software field for quite a while, but I never quite leaned into it as hard as when after ChatGPT, launched in late 2022, and my journey ticked up. Then I started to. You should see my day-to-day browser. I have many LLMs like on top on my browser shortcut bar, because I'm constantly referencing them and comparing them to each other and so forth. So getting an intuition of what's possible with these tools is something that grows a lot through practice. I believe many of them, I pay for a couple, but many of them, or most of them, are available for free for folks who want to dabble without paying. ChatGPT, for example, is available without paying anything. So use them a lot is one of my recommendations. For the and I've attended a number of talks like this, like 100 talks like this over the last few years, where other people have. I'm always happy to learn from other people who are ahead. As far as the math goes, when I got interested in the embedding model and trying to understand that, the math is, I remember some of it from my university days long ago, when I studied linear algebra, and vectors were a pretty good topic there. So a lot of that is in so linear algebra was what we called it back when I studied it formally
Yeah.
in university. But those techniques are they're applying techniques that are very well understood and been around for a long time. So the like I would recommend somebody just go look at the code for the cosine similarity calculation, and
Hmm.
it's entirely old school, well understood vector concepts, and
Yeah.
so have a look and try write it yourself. Write it. The code I shared is in C sharp. Try to rewrite it in your favorite programming
Hmm.
language, and um, compare your results to mine.
Yeah, that's great. So yeah, obviously, you're talking about leadership, and so yeah, the we can do these dot products for the cosine similarities, right? So these are the concepts used here for this purpose. So yeah, that should be, I believe, don't have any questions yet, I believe. So yeah, thank you so much, Bill, for your time. And if you have any questions later on, I will refer it to you. Okay, if we have in the YouTube channel, so I will really refer it to you, and you may answer the questions. So
Yeah.
yeah, and
So
folks,
if
obviously, mhm.
I'll mention, if people do want to shoot me a question, I'm coding out loud on
Mhm.
Twitter/X, and they can feel free to reach out on LinkedIn and ask a question there too. I'll be this QR code will take you to LinkedIn, or LinkedIn.com /Bill Wilder. So feel free to audience, feel free to connect with me in either way if you do have a
Yeah,
question.
yeah, sure. I will also add you like socials and others in the section as well, so that folks can connect with you. So okay, thank you so much, Bill, for your time, and yeah, thank you so much. See you again, Bill. Bye.
Thanks for the invite, Mutual. Take care, everybody.
Thank you for your time, and yeah, thank you so much. See you again, Bill.